Is Milan Janosov. He's Chief Data Scientist at Bauba Insurance. In his talk, Milan will give us a concise overview of the current geospatial data science and location intelligence landscape from sea-level perspective to hands-on execution. We will cover trending data sources and types, including availability and pitfalls, explore potential use cases for several industry segments, and dive into a practical example from data collection to clear insights. Milan, you can start.
Thank you. And hi, everyone. It's great to close this session off. And I promise I'm going to be very brief, just like 2 hours. I only have like 100 slides. So the intro of my talk sounded very technical, but don't worry, I'm not going to dive into the Python libraries and all that, even though my background is in physics and very much in the technical part. But I'm going to talk about maps. So maps are probably one of the most ancient types of data visualizations. And first of all, I also wanted to show you a few appetizers. So a few maps that are kind of hinting how beautiful, how interesting, and also how widespread the application of geospatial data science is. But first of all, what is geospatial data science, and what's this all geographical thing, and how does it link to data science or even physics? Well, the root is very simple. So anything that can be pinned on a map, which has a pair of coordinates like x and y or long and lat, can be taken as a geographical or geospatial data point. And just think about the location of cafes on Google Maps. Think about the navigation apps you use in your cars, or any sort of map you have seen in high school. These are all geospatial data sets and data points. Just like the one you can see here, so this map was actually built in Python. I used a free data set from the United Nations, and it shows all the riverbeds from Africa. So it's a very simple map, even though it covers an entire continent, so it's massive in terms of its physical scale. And still, it can be constructed on a very simple MacBook. So we can see that geospatial data can be used and studied on the level of continents, or even at a global scale, or even if we have the right data, which we have about a few planets, then even we can even create visuals and even create analytics about other planets like the Mars, for example. However, the more interesting stuff comes when we start to zoom in from continents to countries or even to cities. How many of you recognize this city here? Yeah, right. So this is actually Belgrade. So this is the road network of Belgrade, where each line segment is actually a road segment from the city outside of this building. And each road segment is colored based on how far they are from this center location here, which is actually this center where we are currently sitting. And the color map is just a gesture, so it's colored according to the Serbian flag, if I'm right. So the further we are from this point in Belgrade, the closer we are to the blue end of this color spectrum. So again, this looks nice and fun, and it's cool to play around with these maps and print them on T-shirts and posters. But they are also very much the crucial backbone behind, for example, all the routing applications we use, from Google Maps to Waze. Also, these road network structures tell a lot about a city's history. They can help us and help urban planners to understand how to design better cities, livable cities for the future. Or, for example, these road networks also encode why and how logistics systems work in the city, from parcel delivery to how we order food, or how do we order books and they get delivered from Amazon. So again, geospatial data, which can look very nice, but also has serious business impact. Now that we keep zooming in, I would like to bring in another type of data source, which is coming from the space, which is about remote sensing and, in many cases, about satellite imaging. Here you can see from the Landsat satellite, which has been out there orbiting the Earth for about 20 years now, so it's really not the latest technology. Still, it can be used to visualize very clearly how large-scale urban developments take place. For example, here you can see that the Palm in Dubai was built in a few years, and it's clearly visible from space. You can also see that there was this new project. I'm not even sure about its title or its name, but they were trying to build a set of islands that look like a world map. Well, that project didn't work out that great. I guess that they would need better like GIS analysts who can pick up the right map and have them to link them to satellites. Anyway, so we have seen maps on the level of a continent, city, parts of the city like this palm development, but we can also zoom in within a city and focus on different neighborhoods or even collect and analyze data on the level of streets or the level of blocks. This map here is about Budapest, my hometown, but you can get this kind of map from almost every major European city. These maps show the street level or even the block level noise level of a certain point in a city. So it means that the more red or the more orange a point here is, the noisier it gets over there in the city. And if you have ever stayed at a hotel or at an Airbnb which was super noisy, you couldn't get a proper night of sleep, then you can clearly get why these maps are crucial. And if someone is trying to buy, for example, a new flat, then I'm pretty sure that you wouldn't want to buy one which is around one of these red hotspots, because that's going to be a total mess in terms of noise, but also in terms of air pollution. Probably public safety is pretty questionable there as well. So there are numerous aspects here that can be measured using data and also can be pinned on a map using the right geospatial data tools. So now that I kind of gave a hint about how can we use data science to create nice maps, I also want to add a few words about how this actually built up a whole business during the past few years, which is in some parts of the world called location intelligence. The process is very simple, and probably I've already explained it like twice. So the starting point is that we have some sort of a question, a use case, which we want to solve. For example, we want to buy a new flat because we want to make a nice investment, we want to turn it into an Airbnb, and we want to have the right spot. Then we will need to get some data, for which there are countless ways. I will get back to that in 2 minutes. These data can be free, like OpenStreetMap. They can be proprietary, like GPS mobility data from telecommunication companies. And then once we have the data, we can start building models on our laptop, or we can build entire huge pipelines on Databricks. That all is possible and also works very well with geospatial data these days. And once we have that, we can turn them into a few very meaningful, very well-designed and clear insights that can support all sorts of business decisions. So once again, the process, have a use case, get the data, do the modeling. You can also add AI. Today we heard this expression, AI washing here. I think that was really nice and quite spot on in terms of what's happening. So we can use AI for that as well, and then get the right insights and support the decision making. So how does this industry look like? So I just mentioned a few minutes ago that this is a large and growing industry. And after some Googling, I found this very serious market research which actually supports this claim. So it says that the whole geospatial and locational market was about $70 billion in 2022. And it is expected to grow, it is expected to double by 2017. So it's pretty large and it's growing fast. And one of the key players of this field, Carto, is actually surveying the entire geospatial community every year, which kind of highlights how diverse the range of applications is for geospatial data. So if I want to put it very plainly, then anywhere you have locations from the banking sector, where you have the locations of your customers, the location of ATMs, to, I don't know, consulting, governmental and city planning agencies, real estate, of course, insurance, where, you know, for example, in property insurance, the location of your real estate is the most crucial part on how it can be insured, or even in education or agriculture, it's all about locations. So Carto has made this nice survey, and turns out that on the one hand, locational data is everywhere, and use cases are literally everywhere. But turns out that the knowledge is not yet there. So according to their survey, where they surveyed a few hundred execs from these like 15 different industries, turns out that about 2/3 of the companies have both data science teams and teams who are specialized in geographical information system, GIS, geography, so more like the traditional part. However, turns out that only about 1/3 of the companies manage to connect these sites. So the majority of the players here are sitting on a huge pile of geotech data, which they're using for probably just one-off visualizations and analytics, while they also have all the means and tools to create wonderful, huge data pipelines running on the cloud, processing terabytes of data in like a split of a second. But still, there's a huge gap between these two ends because many companies, even though they have geospatial experts and data experts, are not linking these two. However, the next question Carto asked about in this survey was that how much do these companies plan to invest into linking these two sides and building this bridge between data science and GIS. And turns out that, of course, in these surveys, probably the survey question also drives the answer, and people want to like excel well, so they give high scores for the answers. But still, it turns out that everybody who was asked here and who was kind of made aware of this situation said that they certainly want to increase their investment and their exposure to bridging data science and geospatial data. So I've said the word data like 20 times already, so let's take a look on what counts as geospatial data. So probably the most trivial source of geotech data is this little surveillance machine in our pocket, so our phones, our iPhones, which are constantly tracking our location. So even though applications, we can give rights or take away the rights of apps to log our GPS coordinates, which can measure our location down to like 10 meters of accuracy. Still, the cell phone provider companies are, even if we are not using the phone, are logging our location. 5G doesn't have such a great resolution as GPS, but it still can go below 100 meters, so it can fairly accurately predict where do we live, where do we go to gym, where do we work, and for example, where was a customer before they came to our store. So even if we do not grant access to these GPS providers or GPS-based apps, someone is tracking our location. But probably GPS tracks are not the most simple ways of collecting data, but that's maps. So maps have been out there for centuries or even for thousands of years. And today there are a handful of different really great map applications and map data sources. Of course, we know Google Maps, which is great, which is using a lot of public data, but it's not that easy and straightforward, and especially not cheap to use it for large-scale analysis. However, for example, OpenStreetMap is really great for that. Besides OSM, there are a few other players. If you want to dive into the maps and the POI and footprint and road network data, depending on your use case, you can use free sources, but you can also purchase data that are more accurate in certain dimensions. For example, road network, the one that you have seen about Belgrade, is great for many urban planning projects, as it is for, let's say, free. But if you want to do like a self-driving car project, then, for example, that will need much better, much higher accuracy, which will probably need some more sophisticated road network structure, which is available, but probably it comes with a cost. I've also shown you satellite images, which are great, and even the free sources can go down to like 10 meters of resolution, which means that they snap an image every day, and 1 pixel on this image is like 10 meters times 10 meters. But nowadays, the best commercially available technology goes down to like 15 or even 10 centimeters of resolution. So from space, they can see that, I don't know, if I'm wearing a watch or not, which is also very, very comforting to know. And that's still not, that still doesn't mention the part that what military applications could have. Well, that probably goes down to the level of a few centimeters, using also visible range satellites and also like a handful of other spectral ranges, which can be great to, I don't know, for heat source detection and all these things that you can see in like military news reports, which is, again, somewhat disturbing, but that's the era where we are living in. Then the mobility data I have mentioned before. So, yeah, it's happening. There are companies who have made deals with thousands of apps which are collecting GPS logs, for example, from Twitter, from news apps, from web browsers. And these companies aggregate these enormous amount of data about GPS traces. They make them, they clean them, they hash them, they anonymize them. So in theory, no one is able to figure out which GPS log belongs to which person. But from the legal perspective, this is very much a gray area, because if we figure out where a certain person lives, where that person works, what is the typical commuting route that person takes, where that person goes to gym, which all can be figured out from this data that you can buy from a few $1,000s, then, well, you might have just to stand at the right spot on the right corner on the right street, and then you will figure out who that person is. So that's also very nice to know. And that's also kind of the tip of the iceberg, because there are hundreds of data sources out there, from governmental statistical information, from crime data, from environmental things like weather, snow coverage, rainfall, extreme events. There are really great, really cool lighting maps, for example, so you can see where is it lighting on the globe right now. This list can go on for literally for hundreds of elements. So now we have seen, or I've kind of illustrated that this is a market that's out there, it's growing, so there are business cases where geospatial data science plays a role. And it also looks like there is a tremendous amount of data where we can just pick the ones that would probably suit our use cases. And now a few words about the use cases. So here I, again, don't want to dive into the very technical parts, but kind of give a hint about the different questions and the different industry segments where we can use these tools. And the first one is site selection. It's really the most basic one about geospatial data. So the question is that, let's assume that I have 10 cafes and I want to open a new store somewhere in the city or in the country. And I have location experts and managers who know their city very well. They have spent their whole life there, so they have really great expert opinions about where the new cafe should go. But that's still an opinion, and it's not entirely backed by hard facts, by quantitative insights. So this is the point where data science comes into the picture, and we can combine all the data sources that are relevant for a cafe. For example, how far is the nearest, competing competitor coffee shop? How many people live there within, 5 minutes walking distance? What is the typical salary range of those people? So if I want to build a cheap one that targets everybody, then that's a very important factor. Or if I want to do a very fancy coffee shop, then I need a location where people with higher salary usually spend their time. So all this information can be factored in with the right data sources. And once we put these all together, we can actually create a list of recommendations about the possible locations, which could be great for a new cafe shop. And that's the point where the location management and the human intelligence can come into the picture, because we don't want to replace the human insights and the expert knowledge, but we kind of want to give them a better tool which can expand the width and the depth of their search. And also here we can also AI wash this site selection use case, because if we have 10 different cafes or even 100 cafes, and we know the locational information about all those cafes, like a set of features in a nice spreadsheet, and we also have sales information, then we can train a model that can pick up the features that will forecast the top sales in the future. And if we stick to retail and, for example, mobility analysis, we can kind of easily expand this to questions like how many people visit our store based on mobility data. But of course, we should have information about our sales, so we can kind of compare these two and train a model that can compare the visible visitor counts to real-life conversions, which is great if we want to do a competitor analysis, because we know how many people came to our coffee shop, but we can only guess how many people went to the competitor's coffee shop, or how many people are likely to go to a new, freshly selected location. And we could go on and on with these use cases that are coming from the retail or the food and beverages industry. For example, figuring out what are the right hotspots, the right clusters for a good hipster cafe, or which are the best food courts or the best trending food courts in the city right now, which can also easily extract it from this data by adding a few machine learning algorithms. But this is not the only direction or the only industry segment where we can use geospatial data. But for example, insurance is a great spot for that, because if you think about tornadoes, do we have some time or? Okay. All right, just a few slides left. So anyway, in the insurance industry is getting big in locational data because there are so many events happening like tornadoes, flash floods, wildfires that are linked to geographical aspects. So can be tracked from space, for example. We can use historical data from government offices, and these all can be used to price the insurance products right. And after the insurance industry, probably one last example here, which is actually not that commercial. Here on this map, I computed the accessibility time. So how much time does it take to reach the nearest defibrillator device in Budapest? So if someone has a heart attack and needs to get the closest device, which can save lives in that terms, then this map can tell us that which are the parts of the city where these devices are actually approachable within a reasonable amount of time. And for example, if we add one more layer, which is about the population, we can compute that what fraction of the population can reach such a device in, for example, 1, 2, or 10 minutes, which is quite, on the one hand, if we compare this, and I did a comparison between Budapest and Vienna, can be a very shocking example on how easy it is to survive in one city and how difficult it could be in another city. But of course, this is like quite a dark example, but if you replace the defibrillator devices by, again, cafes or ATMs or parcel pickup points, then you can quickly compute the fraction of people that you can reach within like 5 minutes. And then if you compare that with your competitor's location, you already have like the spot-on competitor research which says that, okay, here are the white spots, here are the blind spots. Here you should install new entities, new cafes if you want to be better than your competitor. And these are the places which you should avoid because if you go there, no one will come to your cafe. And probably that was, the last example I wanted to show you. And just a recent article I came across, it lists about 100 different use cases. It's a great review paper, very academic. But if you want to read more about like hundreds of cases, then just go for it. And otherwise, you can reach me on LinkedIn. So hit me up there if you have any questions. Thank you.
Hi, so thank you for presentation. And I have a particular question about Google Maps.
Sure.
So when you have a map, I usually want to see the name of the street. So can you explain why, and what I expect when I enlarge, then I should see the street name.
Yeah.
In Google Maps, it's sometimes you have a range of resolution when it's written, and if you enlarge, suddenly it disappears, and you think, why? Can you explain that?
Yeah, well, I know the frustration very well. Just a few weeks ago, I was finding my way in a city, and I was looking for a particular address, and as I kept zooming in, the street name was like left behind somewhere way over on the map, and I had no idea where it is. Well, probably there's some bug on how they handle the zooming and the positioning of street name labels, but yeah, it's absolutely like a software bug. Yeah, so yeah, don't use Google. Yeah, you know, you should just use these paper maps. I've seen one a few weeks ago at an Airbnb. I was actually surprised to, great piece of history.
So thank you for the presentation. So what do you think should, like, maybe individual data scientists, but also firms do to bridge the gap between, you know, geospatial, which is very important as you have shown, and a lot of the people who don't have these skills or don't think about these type of questions this way?
Well, probably these people should sit down together in the same room. And in my experience, specialists, even data and GI specialists can be very like territorial. You know, they are just protecting their own territorium. So communication is usually is the key, so that they understand that if they work together, then they are not like robbing each other's jobs, but they will like unlock the potential to create something much better together, and they can make each other's job and each other's life easier. For example, a GIS expert doesn't have to repeat the same task 20 times manually in QGIS, but they can just write a Python script that does it for them. Thank you for the question. Sure, go ahead.
Yeah, I wanted to ask, you've shown a very interesting map on the health infrastructure. What's the situation in Hungary? Do you work with your government? Do you have any insights on what's the quality, and what's your assessment and insight on that one, on public infrastructure policies and the important issues mentioned?
Yeah, well, I think that they have much, well, how to say it in a very politically acceptable way. They have much bigger issues than using the right data science tool. So when doctors can get a proper salary, then I think that the last thing that comes up is that we should use AI to provide better services. So I think that the Hungarian health system is in a survival mode where they try to manage day by day, and anything that's innovation is that's great for the Western world. But I totally agree that these things should be listened to, but I haven't found the right ears yet. And yeah, you are from Hungary, right? So you probably... Yep, go ahead.
Thank you very much for your talk. I was wondering, maybe you can recommend some instruments to work with spatial data if we talk about some large data, like when you need to analyze some info at different scales, for example, city, country, or regions, or maybe there are some instruments you use in your day-to-day tasks. Or
Yeah, well, the most standard library in Python is GeoPandas, so it's pandas plus the geo part, and it's very simple and very easy to use. And in my opinion, it can work well if you have up to several 100,000 rows. But if you have more hundreds of millions of rows, then I've been working with Databricks, and Databricks has a few very specialized functions, like a library called Mosaic and another one called Sedona, which are pretty good for these large-scale data sets. Sure.
Hi, thank you for your talk. I would like to actually add on to the previous question. So what kind of tools would you use more for data visualization? Is it QGIS? Is it ArcGIS? Is it maybe GeoServer for the publishing of maps or something like that?
Yeah, thanks. It's a very good question. Here, you can very easily tell that I'm coming from the data world, so I only use Python, and Matplotlib is the basic thing. This map, for example, the river map was also made in Matplotlib, so it's very simple, but there are a few other things in Python for more sophisticated things like PyDeck for 3D, Folium for interactive, so there is a long list of these tools. Actually, I've never even used QGIS or ArcGIS myself, so, but I'm sure they are great tools, and yeah. Thank you for your question.
I also have one question.
Sure, shoot it.
It was quite interesting, the part when you were talking about the positioning of the coffee shops, etc. I'm not a data scientist, I'm an economist, and I just got one hint. There is one very common example in economic theory. I guess maybe someone in the audience may also be familiar. On the very long beach, if you have two ice cream stands, do you know where they will position? In the center, because they want to optimize their profits. So my question is, when you do things like this, do you take care of something else than geo-distribution? And do you employ economists?
Yeah, well, in my team, I had an economist guy as well, yeah, and isn't this the food court effect, just in a different packaging? Yeah, so, yeah, I agree that this is a real thing, and actually I'm planning to write an article about it during the next 2 weeks, so I totally agree that it's a thing and it's usually taken into account.
Okay.
Thank you.
Thank you for a very, very interesting presentation. It was a piece of cake for you. At the end of the very long day, audience gave you so much questions, so it means that it was really good. And I want to thank you on behalf of the organizing team. Here is a certificate of appreciation for your engagement, and hope to see you again at the conference. This is the end of the day, guys. See you tomorrow at 9:30. Thank you for staying with us the whole day.
Thank you.
Thank you so much.